Hello everyone and welcome to the channel. In this video, I am so excited to share with you this new tool called as Gallama. Gallama enables you to run large language models locally but with lot of twists like with function calling, tool calling and various other cool features. Gallama is an opinionated Python library that provides an LLM inference API service backend optimized for local agentic tasks. At the moment, it only works with Llama, and Llama is yet another inference library which uses EXL2 format. There is also in progress feature of supporting llama.cpp Python. There is no OLlama support at the moment and also no support for LM Studio, but I believe that the way this project is going, it might support it eventually. This project is trying to do agentic stuff, but with Maurice, and it tries to remove the issues which we normally see with the agentic stuff like LangChain, AutoGen, Crew AI with local LLMs. So the good thing is that the focus of this tool is on the local LLMs instead of API based LLMs, though it does uses OpenAI's compatible API, which means that you can simply replace it with your existing agentic software as a drop-in replacement as long as you have Xllama running. And we will also see shortly how to get it installed and use. Also, there are a lot of good features around it. For example, as I said that it has OpenAI compatible server. It enables you to have integrated model downloader for popular models like Mistral, Llama, Llama 3.1. It also supports legacy OpenAI completion endpoint because that's been used in so many other software. Function calling, thinking method, which is chain of thought, is also supported. It also supports mixture of agents, which you can implement with tool calling. It also enables you to enforce your format. Plus, you can have multiple concurrent models. That's courtesy to Xllama v2. You can also do remote model management if you like. And if you want, you can even use Claude's Anthropic Claude's artifacts. So this is a quick introduction of it, and I will drop the link to its repo in video's description. Now before I show you the installation, let me give a huge shout out to Massed Compute who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on affordable prices, I will drop the link to their website in video's description. Plus, I'm also going to give you a coupon code of 50% discount on a range of GPUs. Okay, so let's try to get this thing installed. This is my Ubuntu terminal where I'm running Ubuntu 22.04 and this is the GPU card I am using. Let's clear the screen and now let me create the Conda environment where I will keep everything nice and separate and try to use Python 3.12, the latest one. That's always good. Let me press Y here. Let's wait for it to get installed. That is done. Let's install some of the prerequisites like PyTorch and Transformer. Let's wait for it. And these prerequisites are done. Let me clear the screen. Now let's install Xllama, which is another inference library. So I'm git cloning the Xllama v2's library and I have seeded into it. Let's install all the requirements from this repo with the pip command. Let's wait for it to finish. Requirements are done. Let's install all the editable packages from the current repository. Xllama v2 is installed now. Let me clear the screen. Next up, let's install flash attention. This is an optional step, but it improves the performance. So let me do it. And that is also installed. Let me clear the screen. Let's get out of this directory and then git clone the directory of Gallama. And I'm also seeding into that directory. That is done. Next up, let's install all the prerequisites from the source. By the way, you can also install it with simply doing pip install Gallama. So let me run this. Let's wait for it to finish. And that is all done. Let me clear the screen. Now in order to run it, first we need to download the model and Gallama provides you an integrated approach to download the model. So simply do Gallama download and then the model name and its revision from Hugging Face and press enter. It currently supports a lot of models, and if the model is not there, you can simply download it with Llama v2 and use it from there. So let me start it. Let's wait for it to download. After giving few info stuff, it has started downloading the model. So let's wait for it to get downloaded. And the model is downloaded, and it has also updated the model config file which it was complaining about earlier. It's a very new project, so these bugs are expected. Let me clear the screen. Now in order to run the model locally, all you need to do is to run this command, Gallama run, and then the model name. And there you go, your model has been running. You can use your APIs to access this at this port where the UVCon application is running. Generalization initialization is happening. So on the same server, I have opened another terminal, and you can also do it remotely. So what we are going to do it, our server is running with Gallama, and now we can do the inference with it. Make sure that you have this OpenAI installed on your system because it's an OpenAI compatible API, which is quite good. Let me launch my Python interpreter. From here, all you need to do is to import the stuff like import OS and import OpenAI, and then let's set our base, which is a local OpenAI space, as you can see. And of course, it's a local model. We don't need any API key, which is the beauty of this project, which I really like. And then from there, you can do the inference. You can specify your message, something like this. I'm just asking it which is faster in terms of reaction speed, a cat or a dog. Let's do the completion with the help of our OpenAI compatible API. The very familiar stuff. Let's wait for it. So it has done the inference with the Llama 3.18 billion model, which is running locally, and there you go. So it has given you a very fine response here. And of course, we can use our coding to extract this information and present it nicely. And now let me show you how you can do tool use with this Gallama. Again, I have cleared my screen. Let me launch my Python interpreter. Let's import the OpenAI stuff and then specify our base and keys. If you want to list down the models which you have already, you can simply use this command. You can see that for now we already have Llama 3.18 billion locally installed. And just for the sake of completion, again, if you want to do a simple inference, all you need to do is to run this command, and that's it. You see, you can do simple inference with it. Let me press enter few times so that we will have more screen here. Now you can even do it with streaming if you like. Let me show you. I'm just pasting the code from their repo, which you can also check out. So this is our message where we are asking it to write me a 10 lines of poem. We are completing it and then we are printing it chunk by chunk. There you go. How good is that? Typical OpenAI's one. Now let me clear the screen here and then we will do the tool use. Okay, so let's grab our OpenAI's client. We have it initialized now. Let's define a tool. Now, if you don't know what a tool is in LLM, tool simply means that we provide a way for our LLM application to use our external application. In your external application, you have multiple functions defined. So, whenever a user asks a natural language query in simple English, a question from your application, which is AI powered or LLM powered, LLM converts that natural language question into a function call. And that function call is defined something like this, which you can see on your screen. So, for example, if a user asks, what is the weather in Sydney or San Francisco? LLM knows from its intelligence that it needs to call this get current weather function, and then we have told in this tool configuration that this function has these parameters like location and then unit, and location is must. So LLM converts into a function call, and then we can make an actual call from it. So that is the beauty of it. So we have just simply defined this tool or function here, and then let's try to pass it on as a user to the LLM, something like this, where we are asking what is the weather like in Boston or and Hanoi today, and then we are just calling the model. You can simply, let's wait for it, and there you go. Now this is a foreign hide. It has converted the function call here. One thing I was quite surprised because it is saying that model is GPT-4o, whereas I haven't even defined any OpenAI's API key here. But if you look at the response, it is in fact using Llama 3.18 billion. So I think this needs to be fixed there in their repo. I think this is just a typo or something. Anyway, so let me clear the screen. Next up, let's see how it does a chain of thought or thinking template step by step. So for example, we have just defined this thinking template where we are telling it that this is our problem, and then you just need to think step by step, and you can define as much as you like. This is, I'm just giving it as an placeholder, so you can put it as per your own application. So for example, someone says, okay, this is the problem that I went to the market, bought 10 apples, I gave 2 apples to the neighbor and to the repairman. I then went and bought 5 more apples and ate one. How many apples did I remain with? So this is simply a thinking problem. And then from here, you can just use your own model, where you can simply run something like this, that uh, our model is this, and then all those hyper parameters which you can use here, and from there simply you can print the response. So it says that you have 7 apples remaining. So you see that how easy it is to do this chain of thought and then tool calling with this Gallama. So I'm quite hopeful that this project is going to shine a lot in the future, and you already know that how to install fair bit of steps to get it installed, but once it's running as a server, it really looks cool. So that's it, guys. I hope that you enjoyed it. Let me know what you think. If you like the content, please consider subscribing to the channel. If you are already subscribed, please share it among your network as it helps a lot. Thanks for watching.